Hello everyone. In this topic we will take charging of a body. So far we have done that charges are of two types, positive and negative. Like charges repel, unlike charges attract. Charge is conserved and charge is quantized. So we have studied about the characteristics of charge. Now in this class I will tell you how can we give charge to a body, how can a body be charged. But before going into the details of methods of charging a body, I like to give you an introduction of conductors and insulators. In detail we shall be doing it. In many topics we will come about this concept of conductors and insulators. So conductors are, and we have an idea, we have done earlier also. Conductors are those substances which allow electricity to pass through them. So if I take two charged body, for the timing just forget how charge comes, that I will come on. But if we have two charged bodies, charge on it Q1 and charge on to it Q2. Q1 and Q2 may be different, same, or I can even take that there is no charge onto this. Q2 is 0 and I connect them through a copper wire. Two conductors connected through a copper wire. This body also gets charged. This charge is being transferred from A to B if I am using a copper or iron wire. Now if I use instead a nylon wire or plastic thread of jute, then it doesn't happen. So it means there are certain materials which allow charge to pass through them while some do not. So those substances which allow charge to pass through them, we call them conductors, and the other category is insulator. We shall do it later that there is a third category also, semiconductors. That will be done in detail. So conductors and insulators, for the timing it's enough. Now what is so special about the conductors that they conduct? So conductors are, see, every substance is made up of atoms. Inside atoms we have nucleus, inside nucleus we have protons, we have neutrons, and outside the nucleus we have electrons moving around the nucleus. Conductors are these electrons which are moving around the nucleus. They are the bound electrons because they are bounded to the nucleus. They are inside the atoms. Now it is possible in certain material that these electrons, few of these electrons may come out. Then this electron, we call it free electron. So free electron is the electron which is outside the atom. Conductors have a large number of free electrons. So there are a number of free electrons moving around randomly throughout the conductor. And these electrons are responsible for conduction. So whenever we connect, these free electrons may move, only electrons move. Now this also keep in mind that whenever we are charging a body, we will come to all these. Whenever we are charging a body, whether the body is getting positively charged or the body is getting negatively charged, actually it is transfer of electrons only. Electrons are either free, in conductors they are free, and in other materials they are bound to the nucleus. Some electrons may be loosely bound. So these electrons can be taken out of the atom by certain methods. So conductors, those materials which allow electricity to pass through them, metals are the good conductors. They are the best conductors, metals. While those materials which don't allow, such as plastic and rubber, they don't allow charge to flow through them, they are called insulators. And metals or these conductors are characterized by the presence of a large number of free electrons which are outside the atom and are mobile. So we shall be using conductors and insulators, this property, when we will talk about the charging of bodies. Okay. Now, this again we have done this atom, and then we have nucleus with neutron and proton, electrons outside it. Any material, whether it is insulator or conductor, it is made up of a large number of atoms, so it has neutron, it has proton, electron. And when we say a body is neutral, or we consider any body, it doesn't mean that it has no charge. All bodies are made up of atoms, so a number of protons and electrons are there. But atom is neutral. So there is equal amount of positive and negative charge. So atom is neutral means that body itself is neutral. So when we are talking about a charged body, it means net charge is not zero. So every body has a charge. Even a neutral body has charge, but it has equal amount of positive and negative charge. So when we have to charge, we have to create an imbalance. Protons and electrons are equal. If we transfer some electrons, see, neutrons and protons, they are inside the nucleus. It's not easy to take out the protons from the nucleus. We need very large amount of energy for that. Electrons are outside the nucleus, and sometimes for some materials, this energy needed to take the electron out of the atom is very less. So we have to create an imbalance. We can give some electrons to a material, we can take out some electrons from the material, and then there will be a charge imbalance and the body gets charged. Now just try to recall, this is charging by friction. Now try to recall all other examples that we have done in the last class. If I take a comb and rub it with here, or I take a glass rod, rubbed it with silk, any one example we can talk. Glass, and I have a silk cloth. If a glass rod is rubbed with silk, then not in all materials electrons are equally bound to the nucleus. The forces are different. For some electrons, for some materials, the electrons can be taken out easily, while for others it is not. For this particular combination, glass and silk, electrons from glass can be taken out easily in comparison to nuclear. So when we rub glass with silk, we are actually providing energy, and this energy is sufficient to take the electrons out of the glass. So some electrons may be transferred to silk. So what will happen? This gets negatively charged and the glass rod gets positively charged. Because earlier negative and positive were equal in it, but when some electrons are transferred to it, now it has excess of plus charge and it has excess of negative. So there is a net negative charge on it and net positive charge onto it. But the charge coming onto this and coming onto this, they are equal. Charge is conserved. It has not been created. It is just transferred from one body to another. So this is one of the way of charging a body. By friction we provide energy. The electrons are transferred from body 1 to body 2. One acquires plus charge, another one acquires negative charge. Comb, balloon, in all these cases it is happening that electrons are transferred from 1 to 2, and the energy for it we are providing it through friction. So friction is responsible for charging the bodies, and whenever a body gets charged, I'm giving you some other examples. If we take a polyester cloth and we rub this polyester with our skin, we can generate voltage in thousands. actually high voltage itself is not dangerous. We will do all these things in next topic or so. High voltage itself is not dangerous. Dangerous is the current that flows through our body. So thousands of voltage can be created by just rubbing polyester with our skin. Another method, I will give you another very interesting example. Ask your friend to sit on plastic chair. Easily available. Plastic chair, or we call it fiber. So ask your friend to sit on plastic chair and then take a polyester cloth and start beating him with the cloth. And after some time, just check the charge acquired by him. If he stands and touches the iron parts, iron nails, iron tan, he may get shock. So this is one of the way of producing charge. Now, we have produced charge by friction. So I have given you 3-4 examples. Glass, silk, you can produce yourself by rubbing polyester with your skin, and then it can be checked also. And then another example, plastic chair, your friend, and then again polyester. There is another way of charging a body. It is conduction. But in conduction, we need a charged body. We should have a charged body, and then using it we can charge another body. Now, I am giving you a specific example, and then you can apply it to other situations as well. We have body A, body B, and let me say both are conductors. And these are the insulating stands. Insulating stand because if we are not using the insulating stands and we keep them on conductors stand, then what happens actually, whatever charge comes, we have just done conductors allow the passage of charge. So this charge may go to the ground. So no matter how much charge you give to a conductor, if it is connected to earth, the charge doesn't stay on the body. It goes to the earth and eventually the body neutralizes. So if you want to charge a body and you want the charge should stay there, it should always be insulated. It should not touch any other conductor, otherwise charge will transfer there. So I have insulated both these. These are the conductors. Now suppose this body has some charge, and this is, let me say, negative charge. Now I bring this B in contact with it, or I connect them using a conductor, conducting wire. Now this charge will move here, and the reason, negative charge repel. Because of this repulsion, and this is conducting path, so this charge will move on to this and will spread on this also. So some of this charge may come on to this. Now whether this charge will be equally divided or not, it will depend on the size and shape. If these two are identical, then this charge will be half-half, otherwise it will not. There is another quantity which determines the flow of charge, but it is not the quantity. It is possible to transfer charge from a body with less charge to another body with more charge. We will do it in subsequent classes. Actually, it is the potential which determines the direction of charge flow, not the amount of charge. So, but right now, just keep in mind that if two bodies are connected through a conducting wire, charge gets transferred from one body to another till it settles. However, the important part is that if this initially has, say, 20 microcoulomb charge, So 20 microcoulomb before connecting it to B. So when we have not connected it to B, it has charged 20 microcoulomb. After connection, now the charge on A and charge on B, this combined will be 20 microcoulomb, because this charge is shared by the two. So conduction is a method in which charge is transferred from one body to another, and charge is shared by the two bodies. So if a body has minus charge, both the bodies will have minus minus. If one has plus charge, both the bodies will have plus plus. It will be shared, and the net charge of both the bodies after charging will be same as the charge on one body before charging the other one. So it is just shared, and if the two bodies have different charges, different potentials, we connect them, even then it may happen. If one body has plus charge, one has minus charge, then we have to add the total charge, and after connection again the charge will be same. For example, let's take another example. Suppose it has 20 microcoulomb and it has 10 microcoulomb. So what is the net charge before being connected? It is 20 minus 10, so it is 10 microcoulomb. After we connect them, even then the net charge on Q1, Q2 will be 10 microcoulomb. How will it be divided? As I told you, it depends on the shape, size, and all that. So this is conduction. There is another method. We call it induction. In induction, there is no contact between the two bodies. See how? Again, let me assume that this is conductor. Now when we charge a body, whether it is conduction or induction or even in friction, it also matters actually whether the body is being charged is conducting or it is insulating. When we are charging the comb by rubbing it, it is an insulator, comb is an insulator. If we take a spoon and try to do this experiment, it will never happen. Reason? Charge doesn't stay on conductor, it is through our body, it is transferred to the ground. For an insulator, charge stays wherever it is. It doesn't move. But on conductor, it spreads on the surface, and then if the surface is connected to something else, it may get transferred to that point also. So again, I am taking conductor and its insulating strand, uncharged initially, no charge. Now let me take a situation that I bring another conductor having, say, positive charge near it. I bring it closer to it, plus charge. What will happen? This is conductor. We have a large number of free electrons. So those free electrons will be attracted on this side, equal amount of charge. If here we have 10 microcoulomb, minus 10 microcoulomb will come on this side, and plus 10 microcoulomb will remain on that side. Opposite side will have excess of positive charge now, if the electrons gets transferred to this part. Now what will happen? It is negative and it is positive. So positive and negative charges, they get separated here. It is conductor, so we have a large number of electrons. I want that, see, it is not charged, it is still uncharged. Net charge onto it is 0. I want that we should have either minus or plus here. So what can be done? If I connect it to the ground using a conductor. See, conductor allows passage of electricity to pass through. And I told you, actually, positive charge means lack of electrons. Negative charge means excess of electrons. So if here is positive charge, so it means electrons will move to it. Had it been negative, the electrons will move. So positive charge, electrons will move, and now they will neutralize it. This is the second step. First step, you bring it closer. There is charge plus minus. We call it induced charge. Induced charge means which comes there just because of any other charged body taken close to that body. It is not touch. So whenever we bring a charged body close to another one and charge comes on its surface, we call it induced charge, which has been induced because of this. Okay. So positive charge is grounded. But this negative stays here because of this plus. It is attracting it, so it won't be neutralized by this grounding wire or earthing wire. Okay. Now, if I remove it, see, now this will remain here, negative because of this. And now, if I remove it, what will happen? This negative will distribute itself uniformly on the conductor. So we get minus charge. We had plus charge on the charging bodies, we got negative charge. Now see the difference in conduction and induction. Here there is no touch. Another thing, the body that is getting charged actually gets charged opposite to this charge. So in induction, the charge acquired by the body is always opposite to the charge on the body which has been used to charge it. Okay, and charge is equal. There in conduction, charge is shared by the body. Here there is no sharing of charge. So it has plus, and whatever it was, if it is 10 microcoulomb, this is minus 10 microcoulomb. So in induction, the body which is being charged acquires the same amount of charge which has been used to charge it. So this is induction. Now very important, this is, I'm telling you how to charge it. Conductor actually. Now in some cases, when we are dealing with insulators, firstly in friction, I told you that if I take a conductor and try to charge it, it won't happen. Conductor with an insulating hand, it's possible, because it should not go to the ground through our body. In conduction, if I take a charged body and bring it in contact with insulator, then insulator, after taking this charge, because of repulsion some charge may go to that, but it will not spread on the entire surface because it is not a characteristic of insulator, so it will stand. So only a small part which is in contact may get some charge. In induction also, we got positive charge on this side, negative on this side, positive on this side for this particular example. Then there were free electrons, they move to that side. If we are using an insulator, then it won't happen. What happens in case of insulator? So insulators cannot be charged through this method, but even then there is redistribution of charge. I will tell you what happens. If I am taking a positively charged body and brings it, again take the same example, comb, I rub it with the hair and then I bring it close to the paper pieces. Those paper pieces are not charged. So why a charged body attracts uncharged insulating pieces of paper? See, suppose this is a paper, a light paper. Why this is attracted by this? This is charged, but this has no charge. It is made up of a large number of atoms, and if I consider, say if I take two atoms on this side which are closer to the charged body, due to this plus, negative charge will be inside the atom. We have electrons, we have protons. Electrons experience force towards the positive and positive opposite to it. So actually redistribution of charge takes place. So atom starts behaving like a dipole, like initially it is like this, and depending on how large this charge is, so it happens like this. So centers of positive and negative charges, they no longer coincide. We call it polarization of matter. We will come to it later also. It is polarization. And now see, so I can say on this side we will have positive charge, though this is not free charge. We have atom and negative of that atom on this side and positive on this side. Both the charges will experience force, but negative is closer. So it will experience more force and it is attracted by it. So every charged body can attract uncharged one. Charged body can. So actually when we want to check whether this is charged or not, bringing only a charged body closer to it and seeing the attractive force, this is not a sure test of checking whether the body has charge or not. Actually repulsion is a sure test. So we have to bring closer. If I have one positive, one negative, and I am bringing it closer to it, if it is attracted in both the cases, it means this has no charge, it is neutral. But if it is attracted in one and is repelled in another case, it means it has charge. So we need two objects, one with positive charge, one with negative charge, and then we can check whether the body is charged or not. Once it will be attracted, once it will be repelled. But if the body is uncharged, in positive case, negative will shift on this side, in negative this case, positive will shift on this case, and in both the cases it will be attracted. So charged body attracts uncharged bodies. Okay. Now one more thing I want to tell you, how can we check whether the body is charged or not? There is a very simple device, you can make it at home, electroscope. And it is very simple. I will show you an activity. See that also. This is just a conductor, conducting wire. It is conductor. In an electroscope, there is a conducting wire, and here we have two, these may be very light pieces of silver foils or aluminium foil, you can take them very light. Now if I take a charged body, say plus, what will happen now? Induction, negative charge will come on this side, positive on this side, and they all, this is conductor, these are also conductor, they will get positive charge, and since they are very light, so they will be repelled. So the situation will be something like this. This will become like this. They will be repelled. If I touch it, even then now there is no induction, there is conduction. This charge is being transferred to it. It gets positive charge, same type of charge, so it will be repelled. Okay, now another question. If I touch it now, suppose it is okay, I remove this now. Conduction, I touch it, some charge goes to that, I remove the charging body, this charge stays here. Now, if I touch it, what will happen? If I touch it, this positive charge again transfers to my body, or electrons enter to it, it becomes neutral, again this situation comes. So very simple device which can be used, and this, how far they are moving, it tells about the quantity of charge present on them. Okay, so it's all. I am showing you an activity. Please observe it carefully. Thank you.